right? In brief, we can say that we communicate message bits by using a simple coding technique, right? Where we just add an extra bit which is called as parity bit. Okay? Suppose your message bit is 10110. I want to send it as a coded word or coded bits by using even parity. Can you tell me what parity bit I should add? Even parity, even. 1 has to be added. So that total number of ones to be equal to even, right? Suppose same message, if I want to transfer, okay, it has a odd parity coded message. What I should add? I should add 0 to this. That's all. Nothing else. Have you understood this? Okay. This is called as a parity. The concept of parity is very important here. Now this simple adding a single parity bit can only detect an error. That's all. Right? The drawback of this is it can only detect an error. That's all. It cannot detect which bit has the error and how to correct that. Have you understood this, right? So in such cases, we need to go for other coding techniques. There are so many coding techniques are available, right? The second step towards detecting a single bit error, detecting and correcting single bit error, and that coding technique is called as Hamming code. Hamming code, H-A-M-M-I-N-G. Ultimately here, you see what we are doing here to detect or correct an error. What exactly we are doing here, tell me. Can you just observe what exactly we are doing? Something here. What is that? We are adding an extra bit, right? You have the original message 5 bits, but for that 5 bits we are adding an extra bit. So adding extra bits will make your code little heavy, yes or no? But it will correct and detect an error. Have you understood this? Right? See, instead of losing an error, instead of losing entire message, it's okay that I will just add 3 or 4 extra bits to that and make it so perfect that even though there is an error, you will be able to get your exact message. Yes or no? That is very good, right? Than losing everything. That's why you need to understand that this parity bit will be added to the original message. It can be parity single bit, what you have seen now, or it can be multiple parity bits. It need not be one parity bit. There are multiple parity bits are added. Have you understood this? To message signal. So to message bits. Okay? So that's what your coding techniques are. Even now, if you see your all the data communication, there is a possibility that your bits will get corrupted. 100% possibilities are there when it is transmitted through an electromagnetic wave. Right? Transmission is ultimately it's not digital, right? Transmission is going to be electromagnetic wave only. Suppose you go for wireless transmission, right? Transmitting from here to here, is there a digital media? There's nothing called digital media. It's maybe there in your, maybe, it's different. Okay, digital media, you all talk about digital media, it's not that. Digital media for communication is nothing but a wireless channel. But there is a possibility that your data might get corrupted, 100%. A lot of noises, right? So I'm coming to another coding technique, which is called as Hamming code. Okay. Before that, I told you how do you generate this simple parity bit. What we use is simple XOR operation. I'll just go back to Try to understand this. This is very important. See here. How do you generate a parity bit? This is for even parity, okay? Even parity, okay? So you can generate an even parity bit by using a simple XOR operation, okay? Now see here, you can just write XYZ are the message bits, okay? XYZ are the message bits. Now what you get here, this is your odd parity, this is your even parity, okay? Odd parity, even parity. Fine. And you can see accordingly you will get your odd parity or even parity. I can just tell you just one example. Suppose if I take 0, 1, 0, to make it odd parity, the parity bit should be 0, or to make it even parity, the parity bit should be 1, okay? These are the parity bits added for odd parity, these are the parity bits added for even parity, okay? And how do you generate this? It is possible that you can use a simple Karnaugh map and you can simplify and get an equation for XYZ, which we will be doing in our next session, okay? So I am directly putting the circuit here. You can use an XOR gate, okay? So XYZ, you can just check it, give 0, I will just take one example, 0, 1, 0. What is 0, 1? What will come here is 1, right? And you can see parity bit is going to be 1. This is called parity bit generator. This is called as parity bit generator. Have you understood this? Fine, okay? You can generate, this is for even parity, odd parity, you can design accordingly, okay? Which will be done at the next session for you. Fine. And it's very simple to remember. This is parity generator, parity generator. Okay, what is parity checking? How do you check, right, whether you received the data perfectly or not? That is done by another circuit. Simply, you just have to XOR W, X, Y, and P. Okay, now you can check this through the circuit. Okay, now see here. For example, consider same combination. Consider same combination. 0, 1, 0. You have generated a parity of 1 for this, right? Okay. Now, in the receiver, it will check whether you received it in a proper format or not, right? See, 0, 1, 0, 1 is sent, right? You have generated for the message bit, try to understand here. For the message bit 0, 1, 0, you have generated a parity bit and this is transmitted, right? This is transmitted. So X, Y, Z and parity, it is transmitted as a even parity, it is transmitted. So while receiving, you should have even number of ones in this, right? Yes or no? If it is received perfectly, as 0, 1, 0, 1, number of parity bit, number of ones supposed to be even, yes or no? If you don't receive it, suppose instead of 0, 1, 0, 1, if you received it as 0, 1, 1, 1, there is an error, right? That means there is an error occurred. That's an error occurred. And I told you that this simple parity bit can just detect single bit error. Suppose if there is an error in the 2 bits, what will happen? It may not, right? It may give you once again even parity only, and our system says it is correct. It's not. But this can detect only single bit error. If there is only single bit error, it can detect. Have you understood this? Okay. Now assume that your transmitted is 0, 1, 0, 1. Now suppose you have received this. Can you tell me what are you going to get at E? You get 1, you get 0. 0 means no error, absolutely no error. Suppose this particular bit, instead of receiving 0, you received it as 1. What are you going to get here? You will get 1. 1, you are getting 1 here means it is error. It detected a single bit error, It's just detected. It won't say where, which bit, nothing it will say. It's a simple parity. This is not used at all, okay? Now, just for understanding the theory, this can be used, okay? Now, of course, technology is developed. Definitely you need a technique to detect and correct burst errors. Now, there's a lot of data flow happening when you communicate the data. At present, the innovation is so developed that even if there is a burst error, burst of zeros and ones changing, a lot of algorithms are available which can detect and correct the errors, right? And these algorithms are all working based on linear algebra. You might have studied linear algebra in your first year, right? The second year. And those courses are highly useful. I'll tell you, your entire computer science is standing on mathematics. What is artificial intelligence? Tell me. You're all talking about artificial intelligence, which is great nowadays, right? What is artificial intelligence? Tell me. Come on. What is artificial intelligence? It's all algorithms. It's all algorithms. And what is fundamental to those algorithms is mathematics. Make your mathematics pakka, perfect. Then only there is a big growth for you. Otherwise, you just have to end up selling dosas. Right? I'm just using the word dosas, but it can be anything. So make your mathematics perfect. This first and second year you have mathematics. You may be thinking, okay, oh, if it goes done, okay, I'm done with mathematics. No, mathematics is very much required. All these are working on mathematics. All these coding techniques have developed through mathematics. So always you need to have respect on mathematicians. Okay, now let us see what is an Hamming code, right? So try to concentrate here. This Hamming code is very easy. Just try to follow what I am just telling. Certain steps you need to follow, okay? And you need not read this once again after going home if you understood in the class itself, okay? So just see. You know that a parity is going to be added to a message bit, right? And we are sending it, right? That is called as error correcting detecting code. That's the starting point we have seen. Now, what we have seen, the simple parity bit can only detect single bit error. As a next step, we will see another coding technique which will detect single bit error and also correct that error. It will also tell you which position there is an error. And once again, this technique is going to detect and correct only single bit. For 2 bits, this cannot be used. Have you understood this? Have you understood this? Okay, this is very important. Okay, so now you see how does it work? How does it work? It's very simple. Here also we are going to add parity bits, right? Here also we are going to add parity bits, not single parity bit. We are going to add multiple parity bits depending on the message bits, right? Okay, just read this. Hamming code is a technique used to detect as well as correct the error in a 1 bit change during the transmission. If you are transmitting 4 bits, okay, along with that you add 3 bits with a parity bit, okay, if there is any change in the single bit, it will also detect and also it will correct it. That's what it is called as Hamming code. Okay. Now, as usual, I told you for transmitting digital data, we are going to add parity bits. We are going to add parity bits, which is quite obvious from your previous example. There we have added 1 parity bit and we are transmitted. Here we are going to add more than 1 parity bit. Now, how much is the parity bit need to be added? One very important thing we need to remember here, one relation, right? I will tell you what are these parameters. One relation you have to see, okay? 2 to the power of p okay, the same P is equal, greater than equal to P plus M plus 1. I will tell you what are these things, okay. This relation we have to remember, 2 to the power of P greater than equal to P plus M plus 1. Okay, what is this? This is actually used to find how many parity bits are required, okay, for M bit message data. This relation is used to find out how many parity bits are required, okay, for M bits message data, right? Now this relation, we can balance this relation, you can find out what is the value of one of the variable, okay. Now what is M? M is number of message bits. It can be 4-bit, it can be 8-bit, okay, it can be 16-bit, it can be 5 bits, that is length of the message bit, okay. Now P is number of parity bits, P is number of parity bit, okay, number of parity bits. Now what is known in this, tell me? What is known for us? Number of message bits are known to us, yes or no? Number of message bits are known to us. I told you it can be 4-bit, it can be 8-bit, but parity bit we don't know. So how do you get the parity bit now? From this relation, right? Let us take an example. Say let the message bit to be equal to 4. Let the message bit to be equal to 4. Is it okay? Fine. Now, how do you find out your P? Just use this relation. 2 to the power of P greater than equal to P plus 5. Okay. Now tell me what value of P will satisfy this? Let us take starting from 1. Is 1 is going to satisfy? No. Let us take it as 2 is going to be satisfied? No. Let us take 3. Is 3 is going to be satisfied? Yes, 3 is going to be satisfied. You see here, suppose if I take your P is equal to 3, 2 to the power of P which is equal to 8 greater than equal to P plus 5. It's true, satisfied. So now tell me what will be my parity bits, number of parity bits. So number of parity bits is equal to 3. Have you understood now? Now for a message bit of length, message bits of length 4 bits, what is the parity bit now? What is the number of parity bits required? 3. Have you understood this? Okay. Suppose if it is 8, if it is 8-bit, can you calculate it? Suppose if a message bit is 8-bit, what is the number of parity bits required? Calculate it. 2 to the power of P is equal to P plus, what is M? M is 8, right? 9, sorry, it is, M is 8 plus 1, 9. P plus 9. Okay, can you take, of course, smaller numbers are not going to be satisfied, right? Is a smaller number going to satisfy? No. Can you tell any other number? Can 4 works? 4 works better because 2 to the power of 4 is 16 is equal to 4 plus 9. 16 is greater than equal to 13, so it satisfies, right? It satisfies. That means what is the parity bit required for this? What is the number of parity bits required for this? 4 bits. Okay, this is very important. This is the first step towards your Hamming code. Now, what is the total message length now? You know the total length of the coded data is equal to your message plus parity, right? Now, in this case, when your message is 4 bits, okay, and your parity is 3 bits, you got it from this relation. What is the length of the message then now? 7 bits, 7 bits. See this, we are going to add redundancy, yes or no? Your message bits is becoming little heavy now, but at what cost? Detecting an error. That's why we are just adding redundancy here. There's one more coding technique which is used to save that saving, which is used for saving purpose. That is compression. There also you are going to use certain coding techniques. right? And all these things are, unfortunately, you're not going to study in computer science, but you're going to study in information theory and coding in communication, electronics and communication engineering. Okay, right. Now let us see how to code this. See, now in simple parity, where did you add your parity bit? At the rear end, right? You had an option to add it either at the rear end, or else you can add in the first also, doesn't matter, right? Have you understood this? Okay. Now in this case, you can't do that. There is a systematic way of placing your parity bit, right? How to do that? See, you have 4 message bits and 3 parity bits. How do you just keep that message bits and parity bits? There is certain things you need to follow. Let us see that. See here. Now, your total bit position is total 7 bits for this, right? Have you understood this? Total number of, now the message length including your parity bit is going to be 7. Yes or no? So I will just number it 1, 2, 3, 4, 5, 6, 7. Okay? I'll just number it as 1, 2, 3, 4, 5, 6, 7. Now, our parity bits, okay, we add parity bit in the power of 2. These numbers are there, na? Wherever there is a power of 2, okay, there we will add parity bit. There we will place the parity bits. Have you understood this now? This is fine, okay? Now, see here, 1, 2, 3, 4. I will just write it 1, 2, 3, 4, 5, 6, 7. Wherever, whichever number which has power of 2, there you are going to fix the parity bits, right? Now, here we are going to fix how many parity bits? 3 parity bits, right? Okay. See the number. See, try to understand it once again. I am just telling you once again. Those are not concentrating. See, understand this. From the previous slide, we have come here and we have understood that the total message bits, the message length is 7. That means there are 7 bits, including parity bits, right? So where to fix your parity bit and where to fix your message bits in that 7 bits, that's what I'm going to tell you now, right? Since there are 7 bits, I'm going to write a number here, 1, 2, 3, 4, 5, 6, 7. Have you understood this? In this number, there are numbers which are power of 2, right? Yes or no? And in those places, you're going to fix your parity bits. Now, can you tell me, in this, where and all I can fix the parity bit? So 2 to the power of 0, okay? And at this position, I am having my first parity bit, which is the next power of 2. 2 to the power of 1, I am going to fix my another parity here. My second parity bit is going to be sitting here. Now, which is the next one? 2 to the power of 4, and here I am having my next parity. Have you understood this? Right? And remaining 4 bits are going to be your message bits. First bit of message, you put it here. Next bit of message, you put it here. Next here, and next here. Have you understood this? Right? Is it everything fine? Now, what are these P1, P2, P3? Message bits are already there with you, right? Message bits are already there with you, right? Now, how do you get your P1, P2 and P3? These are parity bits. These are parity bits. Okay. How do you get this P1, P2 and P3? And those parity bits, we can get it, okay, from, okay, a simple technique from the other bit position only. I will tell you how to get this P1 bits. See here. Here once again we use that parity bit, okay, as a combination of other message bits, and that parity bit can be either even or odd parity. Okay, see here, listen carefully. This P1, P2, P3, once again it is either even or odd parity, right? So how do you find out that this P1, P2, P3 is an even or odd parity, either even or odd parity? based on based on the message bits, other message bits. Okay, how to do that? See here, your P1 can be calculated by taking a combination of bit position 1, 3, 5, 7. By taking a combination of 1, 3, 5, 7. See here, what is this combination? See, this P is the parity bit, and other bits are message bits. Okay, other bits are message bits. Now see, I told you the parity bit P1, okay, which is supposed to be position 1, it's a parity bit, and this parity bit is actually decided based on number of ones in this bit position 3, 5, 7. Right? So how we got this number? I'll tell you, it's very simple. See, you have P1, P2, P3, okay? You write all combination 0, 0, 0, 0, 0, 1, okay? 0, 1, 0, 0, 1, 1, 1, 0, 0, okay? And 1, 0, 1, 1, 1, 0, 1, 1, 1. Okay, now see here, see this P1. For this P1, see which are all the positions you have 1 here. You have it in 1, right? And you have it in 3, right? And you have it in 5, and you have it in 7, yes or no? So P1 in this is all 1 at 1, 3, 5, 7. That's why you take the combination of 1, 3, 5, 7. Right, I will explain you once again, okay? See here, how do you take the combination of bits? This is P1, okay? P2, P3. Take 0, 0, 0, 0, 0, 1, 0, 1, 0, all combination you take. 0, 1, 1, this is 1, 0, 0, 1, 0, 1, and 1, 1, 1, okay? So this is 0, sorry, something I missed, 1, 1, 0, 1, 1, 1, okay? This is 1, 2, 3, 4, 5, 6, sorry, 0, 1, 2, 3, 4, 5, 6, 7. Fine? Now see, to get the parity bit 1, which are the bit position I have to look, which are the combinations of bit position I have to do? So this P1, this is my parity bit, P1, and then which other bit position I have to take? I should take from 2, right? I should take from 5, right? No, 1, this is already there, 1, P1, I'm already writing it 1 here. Okay, I'm writing already 1. This is called as first position, P1. That is going to be P1 only, right? You know this is P1 only, right? And what are the other position you're going to take? 3, 5, 7. Now see here, in this combinations of bits, this is the one I need to find out, right? These are already known to us. Now how do I find out this? By using simple parity, by using either even or odd parity. Suppose this is 1, this is 0, this is 1. For example, my P1 is decided based on a even parity or odd parity. Suppose if I want to make this combination as a even parity, can you tell me what will be your P1 bit? 0. Suppose if I want to make this P1 as an odd parity, this is 1. This is how we find out the parity bits here, right? Now can you tell me how do you get parity bit P2? What are the combinations? How do you get P2? See, where and all you have 1 here. Where and all you have 1 here? In this P2 position. 2 is already a P2, is the parity only, right? Then next, 3, 6, 7. Now how do you get the parity bit P3? Of course, this is going to be your parity bit only. 4, 5, 6, 7. Now have you understood how to get this combination of bits? Right? So this combination will decide your P4. This will, of course, this is P3 is nothing but in the 4th position only, right? This is 4th position only. This is 2nd position only. So how do you get this P3? Suppose if this is 1, 1, 1, if it is an even parity, what will be the bit P3 here? This will be 1. Now suppose if this is 1, 1, 0, suppose for even parity, what will be the P2? 0. This one. This is, I am taking it an example. See here. Okay, I will just explain you, somebody not understood this. Just, this is very easy. Just, I will take an example. I will tell, 1 minute. Okay. Listen carefully. You have 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, right? This is the total number of a message bit including parity bit, right? Okay. Now in this is your parity bit P1, this is your parity bit P2, this is your message bit 1, okay? This is parity 3, this is message bit 2, message bit 3, message bit 4, okay? This will be given to you. This is already there with you. This is the message to be transmitted, right? But we don't know this. What is P1, what is P2, and what is P3? We don't know. We have to find out that, right? Once again, this P1, P2, P3 is calculated based on even and odd parity. How to calculate that? Okay, to find out those parity bits based on even and odd parity, you need remaining bits, right? Which are those bits? That's what we are going to calculate from here, right? Okay, now, which are those bits? Those numbers, if you by heart, you don't remember sometimes, right? Okay, now for that what you do, simple, you just write a table like this, okay? Simple, write a table like this. Simply write a table like this. This is your P1, okay, P2, P3, okay. Now write all combinations, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 1, 1, 0, 1, 1, 0, 1, 1, 1, 0, 1, 1, 1, right? Now very well you know this is your 0, number 1, number 2, number 3, number 4, 5, 6, number 7. Have you understood this? Right? Okay. Now you see your P1, you have to take those positions. See, P1 is going to be your parity bit only, right? Right. Bit position, I am talking about bit position, right? Bit position, take the bit position. P1, you check where and all you have this 1 here. Where and all you have 1? You have 1 at 1, right? But in the bit position 1, you have, this is P1 only, right? This is your parity, yes or no? You take P1, you take wherever you have 1s, and then where you have 1 here? Which is that position? 3. What is your 3? 3 is going to be a message bit M1, right? This is going to be a message bit M1. Okay, then you take next one. This is in 5. What is there in 5 here? There? M2. Okay. Now next 7. 7, right? So what is there in 7? Bit position 7? 7 you have M4. Now see, you got this combination, right? Now in this, which is unknown, tell me? P1 is unknown, right? Right? And that unknown can be calculated based on the bit 357. Similar technique you have to use, you have studied earlier. What is that? Even and odd parity. Suppose if I want to make this entire combination even parity, for example, if my M1, M2, M3 is 1, 0, 1, Can you tell me what will be the P1 now to make it as even parity? 0. What will be the P1 if I want to make this combination odd parity? 1. This is your P1. Now can you tell me how do you get P2? How do you get P2? Come here. See all bit positions. Okay. So P2 will be bit position, first one will be at bit position 2. What is there in bit position 2? P2, right? In bit position 2 you have P2 only, right? Then you have next one 3. In bit position, what is there in bit position 3? M1. Now next 6. What is there in bit position 6? M3. And what is there in bit position 7? M4. Now suppose if I bit combination as I written here, M1 is 1, M2 is 0, and suppose M3 is 0 example, M4 is 1. Can you tell me what will be the P2 bit for even parity? 0. Now can you calculate P3? So P3 you take this, okay? Fourth bit is P3 only, right? P3 I am writing P3, right? Then fifth bit is what? M2. What is sixth bit? 1, there is 1 here, M3. And what is seventh bit? It is M4. Understood this? Okay. Now I will take an example, it will be very clear for you. Okay, I will just take an example for you. Okay, that's why I said P1 you get it from bit position 1357, P2 you get bit position 2367, P3 you get it from 4567. And how these numbers came I have explained you now. Okay, now let us take an example. Okay, see here. Suppose your message bits are 1111. Suppose your message bits are 1111. 1101, sorry, 1101. Okay, now what is the length of the message? 4 bits, right? What is the length of the parity? 3 bits. What is total length? 7 bits. Just write 1, 2, 3, 4, 5, 6, 7. Okay, which are the parity bit position here? All powers of 2. This is parity bit position, this is parity bit position, this is parity bit position. Remaining are all message bits. Which is your M1? This is your M1. This is your M2. This is your M3. And this is your M4. Have you understood this step? This step have you understood? First step. Okay. After that, what is the work we have? Finding out P1, P2, P3, right? Okay, let us find out P1, right? So, which are the combinations will give you P1? 1357. 1 is P1 itself. What is 3? What is 3? Come on, bit position 3, M1, right? This is M1. What is M1? 1. What is there in 5? 1. What is there in 7? 1. Now, suppose if you are going for even parity, what will be your P1? Suppose if you are going for even parity, what will be a P1? P1 is going to be 1. Go and place that 1 here. Have you understood this? Now, what are the combinations for P2? For P2 you have 2, 3, 6, 7. What is there in 2? 2 you have P2 itself. What is there in 3? 1. What is there in 6? 0. What is there in 7? 1. Can you tell me if this has to be a even parity, what should be P2? If this has to be a even parity, P2 should be 0. You put the 0 here. Fine. Now, next, how do you get P3? From 4, 5, 6, 7. What is in 4 you have P3 itself. And then what is there in 5? You have 1. What is there in 6? 0. What is there in 7? 1. Now tell me, for this combination to be an even parity, what should be P3? 0. You got it. P1 you got, P2 you got, P3 you got it as 0. What is the total message now? What is the total message? For even parity, your message will be 1, 0, 1, 0, 1, 0, 1. Now can you write it for odd parity? Suppose if I want this to be odd parity, can you tell me what will be the bits here? Come on. Suppose if I want this to be odd parity, not even parity, can you tell me what is the bit? Here you will have P1 should be 0, for this 1, for this it is 1. So what is the changes you are going to get it here with respect to this? This will become 0, this will become 1, this will become 1, that's all. So you got a coded, Hamming coded complete message for a message bit of 1101, right? Have you understood this? Now, this is transmitted. Suppose if I am using even parity, instead of 1101, what is transmitted, tell me? 10, 10, 10, 1 is transmitted. Have you understood this? Okay. Now suppose if it is odd bit, what is transmitted? Right. Now, how it can detect an error? Right. There is a possibility that these parity bits may change. Yes or no? These parity bits may change. You have to check every combination once again. Right. See, how do you get P1? P1 you got it from 1357, right? Right. See, P2 you got it from 2367. P3 you got it from 4567. Right. Now, if there is changes happening in any of the bits position here, right, you can easily see that the particular parity will change. Suppose, you see, if there is a change in the bit position 357, this will go as a different parity, yes or no? Right? And this will go different parity, this will go different parity. So, every position of the bit, change in every bit position can be checked using this parity bit P1, P2 and P3. Right? How to do that? Let us see that. Okay? I think I have a small time now. I'll just, have you understood this? Generating Hamming code. This is Hamming code generation. Generation is very important. Right? Checking is very easy. You can understand. If you understand this, checking is very easy. Okay? Just you are going to check the parity bits. Now, I am taking one example now. See here, a Hamming code is received. See, now Hamming code is received as 101011. Right? I am just telling you how to detect an error in this. Listen carefully. Okay. Transmission, you know how to transmit. Right? Now, assume that 1010111 is received. Determine the correct code. See, determine the correct code when even parity is used during the transmission. Assume that this is received, okay, and assume that even parity is used. Now, check whether is there any error in this code or not. Right? How do you check it? Once again, you write your entire bits. Okay. What is that? 1, 0, 1, 0, 1, 1, 1. Which are the parity bit in this? This is the parity bit. This is the parity bit. And come on, this is the parity bit. Now, whichever combination you have used while generating the parity P1, P2, P3, okay, you check that combination once again whether it is even or not. Okay, now check first combination. Okay, first combination you check it as 1357. Take one, this one, right? 3, 5, 7. Check, this is actually even or odd? Even, right? This is even. That means there is no error. Right? Even is transmitted, even you got. Now check the second parity combination from 2, 3, 6, 7. When you check this 2, 3, 6, 7, what is 2? 0, right? What is 3? 1. What is 6? What is 7? 1. See, there is an error here. Yes or no? There is an error here. That means here error is 1. Error is 1. Have you understood this? Here error is 1. That means you have detected one error. Okay? Now, see, and see this one also. See this one also. 4, 5, 6, 7. 0, 0, 1, 1. See, your E1 is 0, E2 is 1, E3 is also 1. Why E3 is 1 here? Why E3 is 1 here? Error 3 is 1 here. Because you have received here odd, but it is supposed to be even. That means the error bits are here. You go from bottom to top, right? You put it like this: E3, E2, U1, E3, E2, U1 is 1, 1, 0. That means there is a sixth position. In sixth position, there is an error. In sixth position, there is an error, right? That means in sixth position, the bit, whatever bit it was originally sent has been changed. Okay. Now see here in sixth bit, what is there in sixth bit? So in sixth bit, it is 1, but it is supposed to be 0. This is the way it can find out. Okay. It can detect an error. Also, it can correct an error. That's all. How it has detected an error? Once again, take the combination and check. If it is not even, then this even error bit error bit will be equal to 0. See here there is an error, E2 will become 1. Here there is an error, E3 will become 1. So you just write the bit combination as E3, E2, E1, and it is 1, 1, 0. That means take the corresponding decimal number, sixth bit. That means sixth bit is having the error. Right? We will take one more example, okay, in the next class, which will be very clear for you. Okay.